All right, we're good. Well, cool. I guess anything to talk about or bring up while we're convening?
Not on my end.
And me either.
Cool.
Nope. My only request is that we have all the counts done by Saturday morning so I can put together our document.
Yep, that's I'm intending on getting mine collected tomorrow.
Yeah.
So.
Perfect. I've already added my information, and my husband only found the 12 pack, so I just counted all 12 bags and just added a couple more things
Cool.
at the
That's
end.
perfectly fine.
Yep, that's just fine.
I bought a 12. I bought a 12 one as well, but I might just randomly select like 6 out of it and do whatever. I think that's what I'll end up doing.
Oh, that works.
That's fine. We've got ours written down. We need to add them to the list, so should see those probably either tonight or maybe tomorrow, Beth.
Cool.
I did, however, just a quick question. I did notice that the way it's currently set up is as if we're testing for the difference. Is that actually what we're doing? I thought we were testing to see if that's the true one or not.
Well, all I did was put the difference kind of for collection purposes. We can, I'll adjust the thing because it's just collecting the data, and that was one of the things I was curious about, how much there was a difference.
Okay, that's
Does that
perfectly.
make sense?
Yeah, that makes sense. That's perfectly fine.
Yep, that's just fine.
But add in any information you want, but leave the difference because I'm just kind of curious. Because one of the questions that it asked was there anything that surprised you? And one of the things that surprised me with mine was that it said 28.3 and there was actually like only 25 in there.
I wonder if the bag is technically part of the weight. Part of me wonders if that's the case.
Maybe, but I only tested the contents of the bag.
The contents of the bag.
I didn't test the bag at all.
All right.
Yeah, and I'm assuming that's probably an average weight, more or less, because like looking at our results that Michaela wrote down for us, it's pretty much a range from 25 up to, I think 30 was our highest.
Yeah, 30 was my highest as well.
Cool.
Yeah, so
well, this is good, guys. It means we have a good range of data, so we'll have something to work with on this test. So that's good.
Question.
Yep.
How many bags?
At least 6.
6?
Mm-hmm.
Yeah.
Of the single serving, which is the 1 ounce bags.
Mm-hmm.
When we do at least 6, we get a total of at least 36 samples collected. So that way we're at least working with the central limit theorem.
Mm-hmm.
Yep. And since I did 12, we'll have more like 40 something.
Yeah.
More the merrier.
Exactly. That's what I thought. It's like, you know what? If I don't open all these bags, I'm going to binge. So I'm going to open all these bags and measure them, and then I can put them away.
There you go.
All right. Are we ready for the review?
I think so. I'm just opening up the Excel file so I have it on file and have it ready for working through problems is all.
Oh, cool.
But I think other than that, I think we're good to start.
Yeah, you guys can go ahead and start. I'll catch up. My computer's still trying to think really hard.
I'm opening up the 2 ones that are listed there, and it looks like we'll need both the categorical and the quantitative.
And the quantitative, yeah.
Sheets, so I'll open those as well. And I think after this review, and I will be ready to take the test tomorrow.
Yeah. And I can't remember. I had 2 exams this week. Does this one close on the 5th or the 6th?
5th.
This one closes on Thursday, whatever day that is.
It's the 5th.
Sounds good. That's what I need to know. Oh, yep, there it is. Thursday at 11. Gotcha.
Next
So on these, real quick, on these meetings where they happen on the week of the exam itself, is there a submission for that? Because I haven't seen it on the last one that I did either, and on this one it doesn't have a discussion board.
No, we don't have to submit it because we're reviewing the exam.
Sure. Okay.
Yeah, it's just kind of basically a study session is really all it is. There's no real accountability as to whether.
Yep, we're recorded in case Adam wants to
correct us on something.
That's about it.
Yeah. Okay,
Yeah.
gotcha. I was just making sure I didn't want to miss out on something or miss this submission. That's good to know.
Yeah, nope.
Yeah.
We just recorded in case Adam asks for the link.
Yep, sounds good.
All right. Are we all ready for number 2?
Yep.
Yep, you guys can go ahead. It's about 10 seconds from being there, so you can go ahead. I'll be there.
So I'm thinking.
Am I correct in assuming the answer to question 2 is chi-squared proportion test? Or chi-squared, I guess chi-squared test of independence?
One set data. Yeah, because they're asking for the education level, so that's a category.
Yeah.
Yeah, they're asking if the level of education and success of startup companies is independent of each other. So,
And it's, yeah, I would agree that it's a chi-squared.
Yeah, and on those, for me, it's easiest to remember is if there's more than one type of variables. Like in this case, there's different countries and different independent or dependent subjects. So
yeah.
There's different categories, and there's
categories.
And there's 2 separate countries, so that are also categories. So yeah, I would agree with that.
All right, number 3. Would that be? I almost wonder if that would be a test of 2 proportions, because in both groups,
Yeah.
one chunk was fired and one was not.
Yeah, it's like what proportion of those under 40 years of age were fired or let go, and what age over 40 was let go?
Yeah.
Yeah,
I want to determine that both groups were treated equally, so I would say that that's a 2.
They're not asking if they're independent or anything like that. So.
And yep, I would say true proportions, because you have the over 40 and under 40.
Yep. So the next one's a proportion one as well. Just
Yes,
saying that
It's just a 1.
It's a test of 1 because we're just dealing with gamers.
Okay.
Yeah.
I heard a grunt from Nate. That makes me feel better.
That's a grunt of approval.
Exactly.
Would that be a paired samples? No. Wouldn't be that.
It says
There.
nothing. Well,
Well, let's see. So 1 turns clockwise and one turns counterclockwise. And we're testing the time difference.
Yeah, we're testing the time. I don't know if it's.
I would say it's an independent sample T.
Yeah, that sounds right because they're independent of each other, and we don't know the standard deviation.
Yep.
So it'll be the t-test.
Yeah.
Yeah, I can go with that.
And it's not 3. If there was a third group, then it would be an ANOVA test. But
Yeah.
Now it's not a paired sample test because I don't know, maybe I'm just thinking it's incorrect, but it's the same 25 students, just 2 different locks. We're just testing the time it takes them to take out and to unlock each of the locks. So I feel like it could be a paired sample test because it's one. They take a test for one lock and then they take a test on the other, and they're basically looking at the difference.
Yeah.
Am I correct in that assumption?
I'm not sure. I'm
A rule
trying to logic through it.
that if you knew the group 1, then it would give you the answer to what was in group 2, or who would be in group 2. But I don't know if that applies to this.
no, I'm not sure that applies to this.
No.
It doesn't say that they were given. It doesn't tell us that there are 2 groups. They just tell us there's 25 students that were asked to participate.
Yeah.
And I don't.
Each student was given the combination to each lock and asked to open the locks. I don't know. Maybe I'm just thinking back to the example that they used for the paired sample T in the sample T test, in which the track coach basically had his athletes run in one pair of shoes and then they had them switch and run again.
Oh yeah, it's true.
And because each student was given the combination to each lock, I'm assuming they're given both locks and they're testing to see if the same students take less time to open the one lock than they do the other.
That's
I
it.
don't know.
Give up.
Still
Question 5,
maybe.
and we're done.
You know what? We've spent too much time on this question, so let's go with paired sample because
I'm down.
I'm good with that.
All right. If we're wrong, we can all blame me, right?
Yep, exactly. It's all your fault.
Yep. Okay.
Okay, the next ones are confidence interval questions.
Yeah.
Yeah.
This one I would say is an independent sample T confidence because it's 2 different appraisers but the same properties.
Oh.
Yeah.
Yeah.
Yeah, it wouldn't be anything else. The only other thing that it could be is paired samples, but it's not.
It's not because we know one person doesn't mean we know what the second person's going to do.
Yeah.
Okay.
I almost feel like this one where it's a percentage, I almost feel like that would be a proportion.
I know. I feel the same way.
That'd be a 1 proportion probably, just because it's one data set.
Is it 1 data set? It's actually, isn't it 2?
Should be 1 for accounting majors and 1 for psychology majors. So
Oh, you're right. I missed the accounting majors. Yep, you're right. So I think it'd be 2.
Okay.
Yeah, the only other thing it could be there is independent sample, but
It's not.
where this is talking about percentages, it's
This is a percentage question. That means it's a proportion.
Yeah.
Oh, they had to talk about Oreo cookies. I can't have it anymore. I don't want to know about Oreo cookies no more.
Well, I had to talk about double stuff Oreo cookies.
Yeah, same thing. Because
Let's be completely honest, those are the only kind of Oreos that people actually pay attention to.
It's true.
Exactly.
Okay. So this is a one sample T confidence interval because we don't know the standard deviation, but we know the mean should be 2 or times 2 of the initial one, right?
Yeah, either 1/2 or 2, depending on the way you look at it.
Yeah.
But yeah. Yeah, you're right. That makes sense.
Any objections?
Nope.
Nope, that sounds correct to me.
Okay.
So for number 9, significance level, that's just the top one, right? The probability of observing a sample statistic more extreme than the one actually obtained,
Yes.
assuming the null hypothesis is true.
Yeah.
Yes.
So I know
good.
that is the right answer. I know that is the right answer just from repetition, but in short words, why is that?
Because the significance level is basically let me look up.
Well, I can look it up. It's okay.
I'm looking up something that Adam gave me in our tutoring session because he said
Oh,
it better
okay.
than I could. Give me a sec. Let me see if I can find it.
Yeah, that's fine.
Let's see. Because we're testing the probability of obtaining whatever it is we're looking for.
Mm-hmm.
That's what it is. That's why.
So isn't the significance level not the probability of? So I thought p-value was the probability of observing a sample statistic more extreme than the one actually obtained.
That is the definition of a p-value, but the notion of the significance level is kind of the same.
Okay.
But
that is true because, well,
Oh man.
I always get mixed up on those two questions between level of significance and the p-value. Every time I take it on an exam, I always mix it up, or I'm saying a too simplified version of it.
mm-hmm.
Because I've always thought that the level of significance is the probability of committing a type 1 error. But I could be completely off on that one.
I'm seeing if... he's just giving me a definition there. Let me see if I can pull something from the other one from the last exam.
The p-value is the probability of getting a test statistic at least as extreme as the one you got, assuming H,
Yes.
yeah, the null hypothesis is true.
That is
so that's correct for number 10 then.
Yeah.
All right. I just did a Google search. It says the level of significance, or the significance level, is the probability of rejecting the null hypothesis.
So committing a type 1 error.
Exactly. That's, yeah. Interesting.
So, okay, so we have two.
Nines
has 2 that. So
yeah, because the only difference in number 9 between the second and the third answers are the whether it's true or not part, because both of them involve rejecting the null. One is just if it's true, and one of it's whether it's true or not.
Right.
So read what you Googled again.
All right. Okay. The significance level is the probability of rejecting the null hypothesis given that it is true. And then in parentheses, it even says a type 1 error.
Oh, well, yeah, there you go then. That's it. Mm-hmm. Well, good job, Douglas. Glad you caught that one. Thank you, Nate, for being ingenious and using your resources.
Yeah, I probably shouldn't do that.
Well, no, I think that's probably
no,
fine.
now we can do that. Tomorrow, whenever you take the test, don't do that.
Right.
Yeah, exactly right.
For today, I'll take it. If we can one and done this, life will be good.
Amen.
Okay, question 11.
It's 95% of all of all 95 confidence intervals contain the true mean.
Yep.
Yeah.
That's the correct one.
I've missed that one too many times to miss it on this.
Exactly.
It seems like such an interesting way to word that answer.
I know. I don't
It is, but it's also true because it says one tip that he gave me was if it has a percentage, you look for the word confidence and true, and that's the one that that's gonna be the correct answer.
Hey, it works for me.
And if it says chance or percentage, it is absolutely wrong.
Makes sense.
Huh? Okay, so for this it would be 0.30 over 100, right?
It's
Or is it the 30?
It's the sampling distribution, or I guess it's p hat. Isn't that what we're looking for basically for it's the square root of p times 1 minus p over n.
Okay.
So that would be 0.3 times 0.7 over 100, square root of that, 0.046.
What was the formula you just used?
So it's the square root of p times 1 minus p over n.
I've got that down as a standard deviation formula.
Oh, I guess that's probably true, huh? Yep. You're right.
I'm trying to see if I have that distribution formula written down. I don't know that I do.
It is buried. Let's see if I could pull it up.
Distribution.
I'm sure it's something similar to that standard deviation equation.
So,
but I just don't know what.
It's x over n equals p hat.
Yeah.
And then
Oh, hold on. The sampling distribution of p hat has a mean of p.
Yep.
Oh, so just be 0.30.
P hat estimates p, so p equals p hat, and vice versa.
Oh yeah, I remember this now.
Then the standard deviation of the distribution of the sample proportions is the one I found, which is 0.046.
And
0.046.
From that, yes, I got the same.
Cool.
I
don't remember how to do this one.
It's where you subtract them, right? 0.25 minus the 0.3.
That like finding the z-score? Is that what we're doing?
Yeah, that's pretty much it.
Okay. That's two. Okay, so p hat minus p over the standard deviation. Okay. Okay. I got 1.09.
3539. Did you get 1.39 or 0.139?
I'm putting it into the app. I don't know yet.
Okay.
Are we using 0.25 as our p hat and
Yes.
0.3
Yep.
as our p? Okay.
And it's less than, so it's a single tail. So you're highlighting everything to the left.
I got 0.1381. What was your z-score? What did you find for your z-score?
It's negative 1.087.
Oh, yep. I rounded wrong.
And I very well could have rounded wrong as well.
Oh, no, I'm looking at it. I did. I rounded wrong.
Okay.
Yep. And now I got 0.139 with the...
Cool.
Okay. Yep, that works. Anybody else get anything different?
0.139?
Yep.
Yep.
That sounds good to me.
Yeah.
My screen changed color on me. Let me save this a little bit. Ah, there we go. Proper screen color.
Oh man, I just love these.
Mhm.
Oh, this is so annoying. Okay, but at least we have the thing out, so I can pull it over. Wrong button. Okay. I'm gonna cover your faces. Goodbye, group. Here we go.
Goodbye.
Okay, so P1 is the true proportion of the people. That take the pill. Okay, so B. Okay, so we have the two experimental groups. So N1 would be the 1563, right?
Yep.
Yeah. Except they're saying P1 let be the true proportion of people who experience dizziness. Well, yeah, so yeah, that's correct. I was reading it incorrectly.
So was I, that's why I was double checking. Okay, and then the control group, there was 579. With 15.
So you guys getting, so P1 is 0.039 and P2 is 0.026?
Yes.
Okay.
That makes me feel better. So, oh, I don't have to change anything there. So P1 minus P2. I got the margin of error of 0.015. Maybe not. Hold on. I can see that my formula is messed up. Okay, I got 0.16.
Man.
Did I hear confirmation?
I'm trying to find the stinking formula for margin of error right now. It's not in the review of different. At least I'm not finding it in there.
So the margin of error equals the z-score times the score times the standard deviation.
Oh, yes. Yes.
Or it's the upper bound minus the lower bound divided by 2.
But since we're not provided with the upper and lower bound.
It will still work, but go ahead and do it with the formula and see if there's a difference.
Okay. When we divide it by n, is it the 2142 that we're doing since it's the entire sample group?
Yeah, I would assume so.
All right, I'm getting, if I did this right, I'm getting a margin of error of 0.002.
Let's see. That was for, hold on. Okay. Actually, for 2 samples, which is what we're working with, we've got to do square root of the 2 plus the 2 standard deviations. Okay. Let me do this. See. That's 1.8.
Oh.
Is that P1 or P2?
I take that back.
I got 0.2 if we're, or 0.198.
All right, so it's P1 minus P2, and then you do the standard deviation, or how? I guess I'm having a hard time with that again.
So the margin of error is the z-score times the square root of the standard deviation of p hat 1, and then plus the standard deviation of p hat 2.
Yep.
Okay.
getting a different. Let's see if I do this.
Don't take mine in account because I think I definitely did it wrong then. So don't use mine as something to use.
So what are we? I'm sorry, I might have missed it. What are we calling our N1 and N2?
So N1 is the 1,563. And
Okay,
N2
then so
is the 579.
Okay, perfect. That's what we need to know.
Living heck, I'm getting 3 different answers. This is very frustrating. Okay. Now let's see. Oh, that's what I'm doing wrong. Forgot to do this. No.
So, did anyone get 0.491 as the margin of error?
No.
Okay.
So here's what I did, and I have confirmation from my hand calculator and on the Excel sheet. On the Excel sheet, they give you the standard deviation of the confidence interval.
Mm-hmm.
So I took those 2 numbers and I times it by the z-score that is also given, and I got 0.025.
Okay.
Oh.
And I did the same thing using it the long way on the calculator. So I'm going to go with that.
Well, I'll believe you. I won't fight you on it.
Not sure why the shortcut's not working with that, but oh well. At least I found the workaround. Makes me feel better. And then what do y'all see as your confidence interval on your sheets?
I've got negative 0.003. Is that?
Yes.
Yeah.
And I have 0.029 for the second, for the upper bound.
Yeah.
So hold on, I'm just verifying that I did this correctly. I might have just used the Excel sheet as a shortcut.
Okay.
So margin of error is 0.0016 or just 0.016.
That's 1. That's not the answer that I got using the long way.
Well, that's the one I just did the shortcut off of based on the Excel sheet. I'm just really confused about whether that's correct.
Yeah, I'm not sure if it's correct or not. I did it. So
I've got the correct confidence intervals, and so the upper and lower bound based on what you guys just said is correct.
Yeah, it is, and I got. Let me do it one more time. this in. So, using the shortcut, I did get your answer. Using the long way and doing it with on both the calculator and using the standard deviations listed above the confidence intervals, I got 0.025.
0.025 is the margin of error.
That's what I got. I'm not sure if the shortcut is right or not, since we all got very different results.
Well, the only thing is, and the only thing that I struggle with is that the confidence interval, the shortcut based on the Excel worksheet, gets us the correct answer because the margin of error is one deviation or I guess it's two deviations and two deviations. Or something like that. Basically, it's the margin of error plus margin of error, or I guess the p hat, I guess is what it is, plus the margin of error and then minus the margin of error. So I think I'm going to keep my 0.016 if anyone is opposed to that.
No.
And when you punched it in, when you're using the deviations or the p-hat values that they have on the Excel sheet, do you have the type of test is not equal to?
No. Let me double check on that. And that doesn't change the confidence intervals or anything.
Yeah, I have to get that.
It doesn't change the confidence intervals.
It doesn't change the confidence intervals. It doesn't change the standard deviations.
Yeah, it doesn't.
Changes the
p-value.
Yeah, it changes the p-value. That's it.
Yeah, that's all it changes. So I don't know.
Well, let's go with either one, and you do that yours. I'll do the 0.025, and we'll see which one is correct, and that way we know which one to do on the test.
Okay.
And I won't be sad over missing 1 point.
Me either.
Not with 45 questions on there.
Yeah. If I manage to get through all these.
Okay.
Right.
Moving on.
Okay. So I think it's the first option since it's different.
Yeah.
Yes, I agree.
Yeah, all we're trying to do is find difference. It's not a greater than or less than.
Okay, my z-score shows 1.458.
Yep.
And that's the not equal to 0.145 is the value that I see. Or are we supposed to use something different?
Fail to reject the null.
So that's the yes, right?
It's
yes, I failed to reject the null. Or no, I failed.
Well, no, because they're saying, is there sufficient evidence to conclude that the proportion of people is different? And it's not.
Yeah.
Okay.
Yeah, if there's sufficient evidence, that means that we did reject
Then we do
null,
reject
right?
it. Yeah, if there is sufficient evidence, there's insufficient evidence, so no, I failed to reject.
Okay. Just double checking that I was thinking the same thing as the rest of you.
You're good.
Okay. Okay, so this is the cheese store.
Yeah.
Conduct a test of independence. Okay.
So test statistic, I got 6.579.
Mine is way off.
If you click out of the input values, it might make a difference. I got 6.579.
Cool.
Oh, there it goes. Thank you. Yes, now it
Yep.
now it matches.
P-value 0.0866 or
Yes.
0.87.
Yeah. So for this one, it would be no, the p-value is greater than 0.05, right?
Yep.
Yeah.
And that means we have insufficient evidence to say that it is independent.
Uh-huh.
Right.
This one's a single proportion, right?
Yep, I think so.
Yes.
So our n is 200 and our x is 50, correct?
Yep.
Okay. Hold on.
Null hypothesis is 0.2.
Oh, yeah. Sorry.
Okay. So where did you get
And then
where did you get the X? I'm confused.
It's from the 50 who outperformed.
Gotcha. Okay. I hate when I was looking for a number like the others and they wrote it out.
so is this a greater than test?
I believe so. Because we're testing to see if they outperform it. So
Yes.
Oh yeah.
Okay, so lower bound, that would be 0.190 then is what I'm getting.
Yes.
Yep.
I got the same.
Okay. And
upper
0.3.
bound of
Three.
oh,
I got 0.310.
Yep.
Ooh, I like these ones.
I don't understand these ones.
I don't necessarily understand the equation, like why it works, but I like that it gives us a relatively clean equation to work with.
Okay. So which equation am I looking for?
So this is going to be one of the n equals equations.
Gotcha.
And in this case, it does give us p.
the margin. Or the yeah, it does give us the margin of error. So it's n equals z over m squared, right?
Times the p whatever p star
Yeah.
minus.
Yeah, in this case where it gives us p star, we can use that, and it'll give us a more exact
Okay.
number.
Perfect. I will click that over here. I'll click this over here.
So when it gives us a margin of error of 2%, do we put that in as a 0.02? I can't remember.
Yes.
Yes.
Okay.
Okay. So
96 over 0.2. squared. 96.04.
And we're using the same z-score that's listed here, right?
Yep.
Okay.
Well, I think the z-score is that one's technically referring to the 1.96 because it's the 95%.
Right. That's right, because it's the 95% confidence level.
Yeah.
Gotcha.
So I got n would equal 1536 point, I guess 1537.
Are you referring to 15.37? Maybe I did that wrong. Give me a minute.
Yeah, I got, because it should be a pretty big number because this is the sample size.
Right.
Yeah, for my 1.96 divided by 0.02, I got 98.
Yep, you're right. I just didn't put the 0.2 on that, so it changed it quite significantly.
Yes, it did.
2 times 0.8. Yeah.
And I believe
1537.
Yeah, 1537. Because on these, you always just round like up, right? Like just to the nearest whole number.
Yeah. You can't exactly sample half of a person.
Yeah. Well, there's some, maybe not ethical ways to do so, but yeah.
Right.
You have to get people for that.
Let's see here.
I'm not sure on this next one.
Okay. I just caught up because I was doing the calculation. I got 1537.
Yep.
Okay. Yay, that
It's
means
going to be
I know what I'm
option
doing.
5. It's supposed to, so P is supposed to equal 0.2, and then we're testing as an alternative is greater than 0.2.
Oh, yeah, that makes sense. Okay. And then, so the next one, that was just the first one, right?
Uh-huh.
Greater than or equal to 10.
Yeah.
Cool. And then the test statistic, I got 1.768.
Yes.
Yep.
Yep.
Value of 0.039.
Yes.
Yep. Okay. And this one, we have rejected the null hypothesis.
Mm-hmm. It's sufficient because, yes, I rejected the null.
Yeah. Is there sufficient evidence to conclude the graduates from top 10 business schools perform better than the other investment?
Right.
Yeah.
So this we're using the quantitative formulas, right?
Sorry. Man, this is a really long one to read.
Yeah.
What kind of test are we running on this?
That's what I was asking. Is it a quantitative or is
This one looks like it's quantitative.
Yeah, because all these are numbers.
Yeah.
Okay.
I actually think we've done this one before, if I remember correctly.
It was.
I'm
It was
pretty
on
sure
one of the
we have.
quizzes. It was on one of the quizzes a few weeks ago.
Yeah. This one's just going to be a sample t-test, isn't it?
Pretty sure.
Yeah.
Yes, pretty sure. Okay. Yeah. So take all of these.
Come on, Excel.
Oh, okay. Please stop. There we go. Copy. Paste. Okay. Is this right? This can't be right. I don't think it's a sample T. Because my T-score is way off.
Wait a minute.
Wait. Maybe if I... So the null hypothesis would be 0.295. Oh,
Yes.
That makes it a little different.
0.295. Yeah, that is the null.
And then is this greater than, less than, or not equal to? The next.
Different, so not equal to, yeah.
Okay. Okay, that makes a little more sense. I feel better. I have a lower bound of 0.282.
What did you say the lower bound was on yours?
0.282.
I got 283. What'd you get for the mean?
288.
0.288 or
Yep.
228?
No, 0.288. Let's see.
And standard deviation?
Is 0.026.
Okay, with an N of 100, right?
And let's see. Yes.
Null hypothesis is 0.295, not equal to.
That's 90.
Interesting that we'd be getting different bound levels on that. And your confidence level lower bound is 0.282?
Yes.
Has anybody else got it to confirm or provide? Maybe I've got it wrong, I don't know.
Yes, Beth.
You got the same as Beth?
Mm-hmm.
Okay.
I'm sorry, my Excel does not want to load today.
Okay.
Mine loaded, but it won't let me change anything.
Is yours in safe
Make
mode?
sure- Make sure you enable editing. That'll let you change it.
Oh, it says my product is unlicensed.
Aha, you stole it.
If you go to the university store, they'll give you a code.
Yeah, I'm pretty sure that's how I got it on this computer, but
If you did any updates, I have to re-put it in every time I do a major update.
I've had to restart it from factory setting a couple of times. And I clicked the your data so that it doesn't erase any of your files, but still don't trust it.
Yeah, I don't blame
Had too many computers do this to me.
Okay, so
I should not be getting a completely different answer from you guys. It's so weird.
and you did the one sample t-test.
Yep, one sample t-test, n of 100, mean of 0.288, standard deviation of 0.026.
Yeah. What's your t-score?
Negative 2.692.
Yeah, that's not the same as mine either. Okay, I'm not sure.
This is problematic.
Yeah. Okay. So you have 0.95 for the confidence level, right?
0.95 confidence level, null hypothesis of 0.295.
Yeah, and you have it not equal to,
Yep.
and you have 100 samples as well.
Uh-huh.
Weird.
Weird.
This is really weird.
How far off is it?
By 0.01, or 0.001.
Okay. Which isn't statistically significant, but
No, but I'm
but
really
there's
interested
only
as to
one
why
right
my Excel is coming up with a 0.001 difference than everybody else's.
hey, adding a decimal or moving the not moving the decimal, moving the what is that? Anyway, just seeing what the next decimal place is
Possible.
because it may have rounded it for you, and I don't know.
Yeah, I mean, it's a 0.2828.
That would be,
But,
yeah, 2, 3.
but yeah, that would go up to 0.283.
Let me see. And since it's there.
I'm going to try one thing and see if maybe it makes a difference.
Okay.
Hey, no, Walmart's hours tomorrow, Scarlett.
All right, well, yeah, I'm not quite sure how I'm getting a completely different answer.
They were open last year.
Okay, I have no idea.
It is a major holiday.
All right.
Stood out.
Well, what we can do is instead of just linger on this, we'll just punch in our different answers and
See which one goes.
yeah, see which one it accepts. I have no idea why my computer's giving me a completely different answer. I've got all the same information put in.
Yeah, it is weird.
Yeah.
That is weird.
That was the upper bound then.
0.293.
Yes. It is weird that that matches, but nothing else does.
Yeah.
The lower bound is off by 0.001, and yet everything else is inputted correctly, but my lower bound is still wrong by 0.001. That just does not seem to make sense to me.
Well, then if you missed this question, I say we just blame it on Excel.
Yeah, there we go.
Actually,
All right.
this is something you should email Adam about.
Yeah, because
that shouldn't be happening because we didn't put in any of the. I mean, there's something wrong with the logarithm.
Yeah.
the whatever the formula that they have in there, if we're getting different answers.
Yeah, I don't know.
But so
I mean,
I've
got the entire sample collected and everything. Like, I don't even know what's wrong.
I don't know. I would save the file, send it over to him. Maybe he can figure out what's causing it for you.
Okay.
But I have a p-value of 0.006.
Hold on. Which question are you on now?
That would be good question. Hold on. 38.
Okay. Degrees of freedom 99.
Yes.
Test statistic was for me negative 2.692.
Yep, and mine is negative 2.0 or 2.803.
Oh man,
Oh, whoa, that's a big difference.
That is a big difference.
that's
Type
weird.
of test is not equal to, correct?
Yes.
Null hypothesis is 0.02 or 0.295.
Yes. 0.295.
0.295. It's all in there. Why is it being so weird?
I don't know. It is really, really weird.
Yeah.
Technology
What's your
is
standard error of the mean? Just out of curiosity on the variable one.
0.003.
We've got all the same information put in there, and yet the only difference.
Yep, or the lower bound and the t-score.
Yeah.
It doesn't make any sense.
Because, yeah, the p-value is the same. Degrees of freedom are the same.
Yep.
This is so weird.
It is really weird. Okay, so p-value of 0.006 saved and moving on.
Okay. Question 39 is, we have sufficient evidence, correct?
Yep, that it is different.
Okay.
Yes, I agree. Okay.
This is another one that we've done before in the past.
Yep.
Yep.
And this is paired sampling that we're going to do, is that right?
I believe so.
Okay.
Isn't this? Gotta pull it up. Hold on. Yeah, this is paired sampling. What does it say they want us to put in variable one? AM height minus PM height. So AM height should be in variable one.
And did we say this was a paired sample or a two sample? Sorry.
It's a paired sample.
Okay.
Because it's AM minus PM, so we're looking for the differences.
Okay. Sounds good.
Okay. Yuck. Okay. Everybody got everything entered in?
Yep, I believe so.
Okay.
For the mean of difference, or I guess, yeah. So the mean of differences is we get 9.591.
Yes.
Yeah.
Okay.
It's a 95% confidence interval. Do we care about the null hypothesis is at this point?
Well, and you guys got a mean of 9.591.
Yes.
For the mean of differences, yeah.
Okay.
So my lower bound shows 8.728.
Yep. 8.728 and 10.455.
Yes.
Type of test not equal to null hypothesis 0.
Yes.
Yep.
Perfect. Sorry. Running a bit behind
You're good.
today.
That's okay. My T-score shows that doesn't look normal.
That looks very
Did you
off.
get 22.446?
Yes, I did.
That seems very high.
That
does
is
seem
very, very
very
off.
high.
So what are we doing wrong? Let's see.
There's a possibility that we're not doing anything wrong in theory.
Well, yeah, because
Yeah.
technically, I mean, a 22.446 would give us a p-value of, 0,
Really small.
Yeah, like tiny, but that's what the p-value it gives us, so it's not necessarily wrong.
Okay. Well, more than one of us got that answer, right? I'll put
Yeah.
it in because
Point
more
four
than
four six. Yeah.
Yeah, that's just Excel doing its thing. I don't think we put anything wrong in.
okay.
We just copy and pasted.
And I have a degrees of
40
freedom.
degrees of freedom,
Yes.
and the p-value is 0.000.
Yep. He's very, very tiny.
Yep, and then we reject the null, saying that yes, we reject, or well, obviously yes, we reject the null, but then is that yes?
Based on the results of the test, is there enough evidence to suggest that the children are taller in the morning than they are in the evening? Yes, because we reject the null hypothesis.
All right.
Sweet. Well, let's see. Yeah, we did.
All right. Cross our T's, dots our I's, cross our fingers, and pray.
Yep.
Now, it looks like I hate these long ones. Okay.
Oh my
Got a
gosh.
90, but what on earth? What did we get wrong?
Yep. I got a 93.02. So
So did I.
Yeah, I got a.
it's interesting that we got the same score, Douglas, because I think on some of them I followed yours, and some of them I followed Beth's.
Well, my test statistic on the one that Beth and I were getting the different answers I got wrong, but I got the lower bound right.
There you go.
That's funny.
Okay, so I got
So,
a 90. I'm not
Did
sure
you guys
what I
get number
missed.
25 wrong?
That's what I'm checking.
I did, yes.
I got
Okay.
29 wrong, so I must have misheard what we decided.
I didn't think we decided incorrectly.
No, I must have misheard it and selected the wrong ones. So I'm just writing down the ones I got wrong so I can
Okay.
do it. Let's see.
I feel like that's correct because the
Yes, I got 25 wrong.
p-value is the right amount. It's greater than 0.05.
Is that one of the ones we all got wrong then?
Did you guys get 6 wrong as well?
I'm checking. I'm scrolling up right now.
Oh, no.
Okay, I got
Question.
15 wrong, so the one.
I got question 6 wrong,
Yeah, me too.
but I didn't get question.
I got.
I didn't
also
get
got
question
5
15 wrong.
Okay, so the shortcut will work on that one then.
Okay.
because
Okay.
I didn't use the shortcut and I got that wrong.
Yeah.
Okay, so I should go with my first instincts. Stop letting you talk me out of them. Yes, I got
Alright.
6 wrong. It's okay. Hey, live and learn, right?
Yeah. Well, I'm thinking I'm gonna probably keep my 93. I don't know if I really want to go through everything again. I've got some other homework I've got to get done tonight.
That's true.
Yep. Fair enough. Sounds
I'm
good.
okay not going through any of them, but what was the correct answer for 29? Do we happen to know?
29 is
It is option 5.
the second to last one.
Okay. That might be why I must have miscounted. Okay.
Awesome.
Cool.
Yep, that's what I did. I confused the two.
Yep, no worries.
All right, I'm going to work on this just because I want to make sure I understand the questions, but you all have a great night.
Yep, sounds good.
Alright.
Thank you very much, all. We'll catch you next week.
Yep,
Sounds
see you next
good.
week. Good luck on the test, everyone.
You
Yep,
too.
thanks. Night.
See ya.
Night.